My name is Emanuele Menegatti. I'm professor of robotics at the Department of Information Engineering of the University of Padova. With the collaboration of my colleague of the Intelligent Autonomous System Laboratory and with the collaboration of our spin-off company, ET Robotics, we developed an innovative visual inspection system within the 3D Complete project funded by the European Union. The aim of the project is to develop an innovative 3D inspection system able to use 3D data about the depth in the object, texture or color information. The result of the project is a visual inspection system able to outperform existing products in the market and to be cost-effective, especially for small and medium enterprises. This is important, especially here in the Veneto region, where there are a lot of small enterprises with a large flexibility in the range of their products. The only way to stay competitive is to guarantee that no parts has defects. This can be achieved with our system that is affordable, very flexible and easy to reconfigure, especially for shorter and shorter production cycles. That's why we created 3D Complete.
Existing quality control systems normally use 2D cameras, which check texture and color, but not depth. Consequently, they have difficulty controlling flexible objects, such as hoses or cables, and detecting low contrast colors. 3D scanning systems, however, are usually designed for 3D reconstructions, so they are expensive and difficult to install in a production line for quality controls. The efficient 3D Complete inspection project, or 3D Complete for short, is a system that combines the advantages of 2 and 3D to create an efficient, user-friendly and cost-effective solution. 3D Complete goes beyond the specifications of the original European project. In the end, the system costs less than €3,000 to build. It is also easy to configure and versatile, as it can check an array of different sized parts and products from a car engine to a mobile phone. What is more, it is quick and easy to install in a production line and is also affordable for small and medium enterprises.
During the project, the scanning system has seen 3 different redesigns. Initially, we started with a manipulator arm, which is carrying the scanning head, composed by a camera and the 2 lasers. But this was not optimal for production lines, for integration in the production lines. However, it's very good to scan complex objects like this one. In a second step, we moved to a conveyor belt solution in which the parts are moving on the conveyor belt like in a real production line, and the scanning head is fixed to a support over the conveyor belt. In the first implementation, we needed to have the part passing twice under the scanning system. In the first pass, we get the depth information, and in the second pass, we get the texture information. A third improvement, so the third step of the scanning system, was the ability to have the part just passing once under the conveyor belt in order to achieve a faster scanning time. And this was possible thanks to this commercial system, commercial illuminator, that is generating a narrow strip of light and just in the middle of the part, and so we were able to get depth information and color information at the same time with one pass. Unfortunately, this commercial part is rather bulky and expensive, and so it's not easy to integrate it in a scanning system attached to a real production line. We have another spin-off company in our department called LightCube, and they are expert in the design of LED illuminators. They were able to create for us a new illuminator, very compact, very small, and very cost-effective, which can generate a narrow strip of light, even narrower than the commercial solution, and this enables the scanning system to dramatically improve the scanning time and the quality of the reconstructed image and analysis.
The 3D Complete scanning system is composed of 2 lasers and 1 camera. The lasers hit the item and enable the camera to capture it. The information is then sent to a computer which uses a trigonometry equation to calculate the item's height. When the item passes beneath the scanner, the system measures the height of the different parts line by line. The result is a cloud of points that creates a height map. At the same time, the system captures the illuminated slice of the item's texture, and it reconstructs a top view of the item by stitching the slices together without distorting perspective. The top view image enables the item's original color to be added to each point of the cloud. The end result is a geometrical 3D model of the item, complete with texture. The system maps the item's entire geometric structure and appearance onto a computer. It performs a real-time quality control by comparing a scan of each item on the production line with a model of the perfect item stored on the computer. A number of complete quality controls have already been carried out, but additional ones can be conducted in accordance with customer needs. One of the major strengths of 3D Complete is that it uses a single system to perform classic quality controls. For example, check colors, recognize optical characters, and read barcodes, alongside standard 3D scanner checks for size, angle, and low contrast colors. One example is checking whether a component is plugged into a board properly. The gold module on this sample PCB needs to be securely mounted onto the board. The system measures the angle between the surface of the gold module and the board. If the difference is more than 1 degree, the board is detected as faulty. This sample PCB needs to have its fuses checked. This is particularly difficult to do with a traditional 2D system because a fuse is mostly glass casing with a fine filament, and its ends are metal caps that are the same color and shape as their clips. Here, 3D Complete uses depth information to detect any missing fuses. Cable position can also be checked with 3D reconstruction and analysis. 3D Complete was designed to visually control a range of products, including circuit boards, automotive components, metal assemblies such as this gas burner of a heating system, plastic molded parts, or the panel of a washing machine, which can also be checked to determine whether its buttons and clips are correctly molded and in place. All of these items can be checked with 3D Complete. The 3D Complete system exceeds the specifications of its initial design. The final version has a scanning time of 0.5 of a second, a resolution of 0.04 mm, and the inspection time for an average board is 1.5 seconds. With specifications like these, the production cycle does not need to be slowed down to achieve 100% fault-free products. What is more, setting checks and the features to be inspected can be fully automatic, so the system does not need any input from operators. Alternatively, specific checks can be set in advance with an intuitive, user-friendly interface. Just click the parts to be inspected and set the required tolerances. To conclude, 3D Complete is easy to integrate in any production line, can check product texture and geometry, performs visual controls that traditional systems cannot, and is also affordable for small companies.